Let's look at the buzz today to see what we should have already turned in and what is due for this week. So I'm going to pull up the student account here that I have, and let's look at Algebra 2. So if I go to this grade screen, remember I can go up here in the menu and go to grades, or I can click this little icon. I'm going to click the icon. I can see that August 29th, last Sunday, these three things were due, the pretest and then 101, 102. That was due last Sunday. This week we have a one question quiz, one question, and then we have 103 and 104 are the lessons we are doing this week. Last week we looked at solving systems of equations algebraically and graphically, and that was with linear equations, right? Straight lines, linear equations. Now we are looking at non-linear equations, which can get all kinds of crazy stuff going, right? We can have parabolas, or we can have, all kinds of radical functions, cubic functions, absolute value functions, all kinds of different things when we get outside of just lines and linear. So we're going to be looking at that. Let me show you the one question quiz. I can't show it to you that way. I got to go back to the activity screen. One question quiz. It really is just one question. It gives you a graphing problem. With that graph, what is the solution to that system of equations? So from the lesson 102, you should know which one of these options is correct. Quick one question quiz, which will give you a evidence of learning grade, right? So we'll actually have an evidence of learning grade from that instead of just practice and homework grades as we are doing this year. But we have two lessons. We have the solving systems of nonlinear equations, which you should learn after this lesson. How can elimination substitution adapt to solve a system of nonlinear equations? So factoring trinomials by grouping, solving by completing the square. Man, remember completing the square? That's a bit back in algebra there. Completing the square and all that fun stuff. But here is review on substitution or elimination, which we just did in our last problems. But this is a review. If you want to go back and look at that, be sure and check those out. Or you can also use by the quadratic formula, right? We have the quadratic formula we can use if we want to solve this. So with quadratics, you've got options: vector by grouping, completing the square, quadratic formula. But I'm going to pull up my camera here, and we are going to look at some live examples. All right, so let's say, for example, we're going to solve this systems of equations, and our first equation is y equals x squared. Oh, notice we're getting out of linear right away. Now we're in a quadratic. Minus 7x plus 10. And our second equation is going to be 3x plus y equals 7. Now this one is linear. It just has an x. Right, this one is quadratic, so we have a mixture of linear and quadratic, and we're wanting to solve this and find out what is the point, what is the xy point, what is the x and the y that would make that true for both statements. So in this case, when I look at it, the first thing I notice is I already have one of mine that's in a y equal, which makes it look like it's perfect for substitution. Since that's what y equals, I'm going to substitute that into this second equation. So I've got 3x plus, and instead of y, I'm going to put what y equals. Y equals this, x squared minus 7x plus 10. Now, if there was a coefficient out here, if this had a 2y or negative 3y or something, Then I'd put parentheses around this with the 2 or -3, whatever's out front, and I'd have to distribute that. But in this case, I don't have anything but just a y, so I really don't have to do the parentheses. And it still equals 7. So you can see we've taken y and we've substituted what y equals. Now we just have x. We have like terms. We have a -7x and we have a 3x. So we can combine those. So that leaves us with x squared, 3x minus 7x minus 4x plus 10. Okay, so we just simplified it by combining like terms. And now we need to figure out what x is. To solve a quadratic, remember it just said we can factor, we can complete the square, we can use the quadratic formula, but we're going to set it equal to 0 because all of those generally need us to have it equal to 0. X squared minus 4x plus 3 equals 0. So we can use the quadratic formula if we like. And we got that negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember the quadratic formula? Where we could take a, b, and c, a being 1, b being -4, c being 3, substitute in there, and it'll give us our two answers. Or this one looks like it's factorable. So we can find out if this is factorable or if this is going to work by just taking the part that's underneath the radical and seeing, is that a whole number? If that's a whole number that's greater than 0, there's going to be two answers. If this part right under here equals a 0, that means there's only one answer. And if this is a negative number, that means there's no solutions to this. No solutions. So let's just check that b squared minus 4ac part. So we said b was -4, so -4 squared minus 4 times a is 1, c is 3. -4 times -4 is 16, minus 4 times 1 is 4, times 3 is 12. Okay, so that equals 4. Everything underneath equals 4. That means there's going to be two solutions because we have a whole number that's greater than 0. So it's going to be some nice factorable two solutions. If this was a number that was greater than 0 that was not a whole number, it was a decimal or something like that, then there still would be two solutions, but they wouldn't be, this would not be a factorable. It'd be some weird solutions that have a square root number, and we would need to use the quadratic formula if this was not a whole number. But since this is a whole number, we'll be able to factor this. So this will factor into two binomials. And we need to take this 3. Remember, it needs to be multiplied together to be 3, but add together to be -4. So if we want 3, we can have 1 times 3, or we can have -1 times -3. Both of those would end up with 3. But when you add them together, this is 4, this is -4. We need the -4. So this is our two factors, -1, -3. So x minus 1 times x minus 3 equals x squared minus 4x plus 3. So we have our factors for this equation. So let me ask you, if I have two numbers, so this is a number and this is a number, this number times this number, and it equals 0. What do we know about these numbers? Somebody turn on the microphone or type it in chat. Let me know. What do we know about those two numbers if we're taking these two numbers, multiplying them, and they equal 0? Anybody?
Maybe that only one of the numbers will be 0.
Well, definitely one of them has to be 0, right? Maybe both. We could have both numbers equal 0, but one of them has to be a 0. There's no way we can multiply them together and end up with a 0 unless at least one of those numbers is a 0. So either this has to be a 0 up here, or could be this one's a 0. It doesn't matter which one. In order for this to equal 0, either this has to be 0 or this has to be 0, or both. But they can't both be, because if the x makes this 0, that one won't be. So add 1, add 3. So if x equals 1, then this is going to be 0. or if x equals 3, then this will be 0. So that's two different solutions for this system of equations. One of them was when x is 1, and one of them was when x is 3. So now we need to know the y's. So this has two solutions. See, with linear, we only had one solution. Two straight lines can only cross in one place, or never, or they're on top of each other. But with nonlinear, we can have two solutions or more, depending on what kind of equations we're looking at. So we can now use this 1 and this 3 in either equation. This one looks a lot simpler. So let's go to the 3. Let's substitute the 1. So when x is 1, this equation, 3 plus y equals 7. We'll subtract 3, y equals 4. So this is one of our solutions right there. Our other solution will be 3 times when x equals 3 plus y equals 7. So 9 plus y equals 7. Subtract 9, y equals -2. So when that's 3, there's our other solution. Now, just like the linear equations, we can put up a graph. I'm going to delete those old equations. And we can graph these two. Y equals x squared. You can also use the little, down here it's got an a squared, like whatever the a is. Or you can use the shift 6 to make the squared part. Minus 7x plus 10. Okay, so I'm going to hide your little keyboard. So there's the first equation we have in our two equations. And the second one was linear, and it was 3x plus y equals 7. So we see right here, there is a place where both of those cross each other right here. 1, 4. That was one of our solutions. Our other solution is at 3, -2, which is right there. That's the two solutions to that system of equations. That's the two solutions. So we can see that by graphing to verify that we did the algebra correct. All right. Verifying did the algebra correct. So let's see. So this is something that you will get in lesson. The first lesson is doing this algebraically. We could also do this by elimination. We can rearrange this equation to be y equals, move the 3x over. We can make one of those y's go away by multiplying by -1, adding them together, but we would still end up having to factor it because there is an x squared in there. At some point, we're still going to have to figure out the two different x's that make that true. We would end up with the same solution, right? Because it doesn't matter how we solve it. There's only two places where those two graphs will intersect. That's the only solutions. So we can do it by elimination or by substitution. Our lesson will give you examples that will walk you through and doing that with different kinds of problems in addition to this one. Let's see, something else we need to know how to do this week is how to write a piecewise function. A piecewise function. So I'm going to look at this example that we have from our text right here. So this says, Autumn is ordering t-shirts for a soccer team. The company charges the following prices for t-shirt orders. So up to 10 shirts, she pays $25 each. 11 to 20, price goes down to $20 each. If you order 21 to 30, it goes to $15. If you order more than 30 shirts, you can get it for $10. So he wants to sketch a graph of the system and determine how much she spends if she orders 23 shirts with $15 shipping. So we need to know how to set up a piecewise function. So with a piecewise function, f of x equals, it's not just one equation because we have 4 different scenarios. All right. And so we said up to 10 shirts, which includes 10 because 11 is the new price. So anytime x is less than or equal to 10 and greater than 0, right? Because 0, you don't pay anything. If it's greater than 0, so 0 to 10 shirts, then this is going to be $25. There's no equation I mean, it's not like, well, it's 25 for each shirt if we want to know how much each shirt cost. If we are 11 greater than or equal to X equal to 20, here, we'll just say greater than 10, because even though in this scenario, we can't order 10.1 shirts or 10 half shirts, let's just set this up 20, anything greater than 20 shirts to 30, including 30. And then if 30 is less than X. So this will be $20, this will be $15, this will be $10. Because this is our piecewise function, and these are all a constant function, right? This is just a horizontal line when we graph these. Sometimes when you're setting up a piecewise function, you may say, well, depending on the graph, if X is less than 0, then I want the graph to be 3X minus 2. If X is greater than or equal to 0, then I want it to be the graph of X squared. You can set up a piecewise function, anything. I'm just saying I want a piece of this graph anytime X is below 0. I want a piece of this graph when it's greater than 0. But for this scenario, we're just trying to figure out prices of that. So graphing that, I'm going to make a graph for this. We're supposed to sketch the graph. So I've set up my equations. So for my graph, I'm going to say, okay, I'm going to go ahead and set these at 5. So this is 5, 10, 15, 20. This is going to be my prices of shirts, right? And then I'll do these the same thing, 5, 10, 15, 20, 25, 30 or more. So anytime it's greater than 0 and up to including 10, it's 25. So if I graph that, I'm going to use 0 is not included. So I'm going to put a hollow circle there. And it goes up to 10 shirts, and that is included. And it's 25 that entire time. So if I want to know the price of 5 shirts, I can go here and say that 5 shirts cost me $25 each. $25 each. 10 to 20, not including the 10, the Y is at 20. So not including the 10, but up to 20 shirts, which is included, I pay $20 per shirt. If I want to pay $15, that's between 20 to 30. 20 not included, 30 is included. And then $10 on anything over 30, not including 30, but everything. And that's just going to be an arrow, because if I order 100, I'm still paying $10 a shirt. There's no further price breakdown. So that's how I'm graphing this piecewise function. If I wanted to graph this one by comparison, let's say I had a piecewise function like this, 3x minus 2. I might need to plot a few points, right? I can say, okay, so an xy point, if x is less than 0, so let's do -3 and -1. -3 times 3 is -9, minus 2 is -11. -3 times 1 is -3, minus 2 is -5. So when I'm graphing that, I'm graphing these points, -3, should be about right there, -3, -11, and -1, -5. So I'm doing a line. This is a linear equation, right? It goes up to 0. When x is 0, it's at -2, but that's going to be a hollow circle. And when I graph that, it's going to be a line that looks like that. So there is the first portion of my graph. And then I said anytime it's 0 or greater, I'm going to be x squared. So at 0, it counts 0. 0 squared is that. Let's see, 5 squared would be 25. 3 squared would be about 9. It's going to look like, see, it's a quadratic, so it's going to be curving. It's half of a quadratic. So that would be a piecewise function for this equation. for that function right there. So just depending on the graph that you have, what pieces you're using, I'm using these 4 constant equations, 4 pieces. This, I just have a 2-piece piecewise, and one of them is a quadratic, one's linear. So this one's straight. This one's part of a curve. You know, the other half of it would go up that way, but we don't graph that because we're only using this graph when x is greater than or equal to 0. That's the only time we use that one. So we'll have that in our assignment this week, having to put together a piecewise function and sketching a graph of that. So I want you to see a couple of examples of how we did that. So that is in our lessons this week. With nonlinear equations, here's the most common examples that we're going to be looking at, typical examples. The constant function, which we just did with that piecewise, you know, like f of x equals 3, f of x equals 20, whatever. It's just a horizontal line wherever that constant is. The range is only that constant number. Domain's all real numbers. Linear functions, when it just has an x. Quadratic functions, when there's an x squared is the largest exponent. Cubic functions, when you have x to the 3rd power. Radical functions, when you have a square root of x, right, where the domain and range is limited to be larger than 0 because we can't have a negative number underneath the square root. And since that can't be a negative number, the result of that is not going to be a negative number either. So that limits our domain and range. Absolute value, we could have absolute value. And when you have absolute value, that's just how far is it away from 0. So if x is -5, which we can have a -5 in the domain, how far is -5 away from 0? It's +5 away. When we take measurements, it's always a positive number. So all real numbers greater than or equal to 0. This will not be a negative range. When you graph it, everything's above 0, 0 and above for absolute value. Rational function is when x is in the denominator. So you can have all real numbers except 0, right? We can't divide by 0 or the sun explodes or something weird. You know, can't do that. Cannot divide by 0. Your calculator doesn't like you do that either. So we can have negative numbers. We can have positive numbers. We can have little bitty decimals. We can have huge numbers. We just cannot have 0. So that's what our limit is on our domain and range. So that is some common functions we'll be looking at in these lessons. There's another example it gives you in the lesson of a piecewise. This one did absolute value and -x minus 3. X is less than or equal to 1, greater than 1. So it had a linear and then absolute value. Now, if the absolute value continued, absolute value goes down to 0 and then goes back positive that direction, right? If that was continuing, it would do that. But we don't have the red portion of the graph because this is a piecewise, and we only use that graph when x is greater than -1, or +1. So when x is greater than 1. So we only use that piece of that graph in this piecewise function. So, all right, what else do we need to look at in here? It will have the graphing in here, where we can just take these and put them on a graph and see the solutions, which we did that. We looked at that on Desmos. Sometimes these piecewise won't have a solution. There's no solution in this piecewise if you're trying to do a solving a system, because there's no places that they meet, right? So that's just graphing a piecewise. So let me show you before we get out of here then. So you'll have one lesson on doing this algebraically. Algebraically, that's where we did all of this, the substitution. Then the second lesson is over being able to graph it. So you can go to Desmos and you can graph those and find where they meet. They may have more than one solution. If this is x to the 3rd, it may have 3 solutions. If it's x to the 3rd and linear, it could have 3. It could have 3, could have 2, could have 1, could have 0. It might never meet. It just depends on what you have. But let's look at what is our actual assignment this week. So I'm going to show you in Buzz where to find this, because otherwise I will get some emails. People say, I can't find where this week's assignment is. For 103, that one's in there. Hit start. You've got your multiple choice, 5 multiple choice on solving these systems equations. What's the solutions to this? And you can, here's when you can substitute, because it's y equals, you substitute that in there, find the factors. Is it one of these or is there no solution? All right, so you have 5 of those. Then you get, I won't leave that. Then we get over here to 104. And when you go there and you say, I'm going to go to the assignment in 104 and look at that. And when you get here, this is all it shows. It doesn't have a start button. It doesn't have multiple choice questions. It's just got this submit my work and a plus, add an attachment. You can either type here or you can add an attachment, or you can do both. You might want to type some stuff. If you do your work on paper, you can take a picture of it. You can do it in a Google Doc and attach a Google Doc, however you need to attach files or type in here. But let me show you where the assignment. Up here it says submit your completed assignment following the instructions in the lesson. Let me go back here. So if I go back to the lesson, there are 6 pages on this. And when you go to the last, go through all the lesson, all that good stuff. This has some videos, good video talking about graphing and how to solve. That's just a 2-minute video. Some more examples down here, graphing. But when you get to the last page, and you get down to the bottom, now note this says, for the assignment on page 6, you're choosing option 1, work alone. We're not going to break up in groups because otherwise work collaborative where we assign groups, and we're not going to try to do groups. We're going to do just the work alone part. So when you click on option 1, here is the assignment. It's at the end of the lesson. So I have this printed out so we can see it all on one page. I don't have to keep scrolling up and down. And here is what you have to do for lesson 4. And again, you can do this on paper, you can do this on a Google Doc, you can, however you need to do this. So this says, after a dreary day of rain, the sun peeks through the cloud and a rainbow forms. You'll notice it's in the shape of a parabola, and it gives us the equation right there for this parabola. Y equals negative x squared. See, the negative out front makes the parabola go down instead of up. Plus 36, so that's where the y-intercept is, at that plus 36. And so there's a rainbow. So in the distance, an airplane is taking off, right? As it ascends, as it goes up, going up, during takeoff, it makes a slanted line that cuts through the rainbow. So at some point, it's going to cut through your rainbow, right? At 2 points. Create a table. So here's your first thing you're supposed to do. Create a table. At least 4 values for the function that includes those 2 points of intersection. So wherever your plane crosses through there, that's going to be 2 of your 4 values. Wherever you decide that your plane is going to cut through there, between the airplane and the rainbow. So you're going to pick 4 points along that line that the airplane's route is taking, a linear function. Okay, so that's number 1. Number 2, analyze the 2 functions. All right, so answer the following reflection questions in complete sentences. And I'll tell you, like in math, if this is your answer, this is a complete sentence. Y equals negative x squared plus 36. In math, that's a complete sentence. But you may have to actually use words to answer these. So you have to say, what's the domain and the range of the rainbow? And what does that represent? Explain. Don't forget the big explain words. Explain. And do all of the values make sense? Why or why not? All right. So the domain. So the domain of this, it looks like it goes from negative infinity to infinity. Looks like the range goes down to negative infinity. Does that make sense? Does it make sense that you would have negative infinity in the domain or in the range? Next question. What are the x and y intercepts of the rainbow? And what do those represent? Explain that. Is the linear function, that's your airplane, positive or negative? Explain it. Did you make a positive function or did you make a negative function? What are the solutions or the one solution to the system of equations created, right? What are solutions? When we have system equations, you should be able to tell solutions and explain what it represents. What is that solution? Okay, so that is all of the assignment related to this. Now, this is a totally separate problem down here. This has nothing to do with this up here. This is totally separate problem. Number 3, create your own piecewise function with at least 2 functions. right? Because we did one that had 4 different functions and we did one that had 2 functions. You have at least 2 functions. And then explain how to graph it, and then graph it. You can do it by hand if you just want to draw a graph, or you can use a graphing software, take a screenshot, whatever, and submit the graph. All right. So tell me how to graph it and then graph it. Create your piecewise function. And so when you create it, that's when you're going to do that on paper like I did. I'm going to have, here's creating a piecewise function. This is creating a piecewise function. So you would have all of this information. When to use this piece, when to use this piece, when to use those 4 pieces, however many pieces you make. So this has nothing to do with the airplane or rainbow. You're not using this as a piecewise function. That's for one thing. There's no designation of when to use which piece. These are all complete graphs. So this is totally separate. Don't want you to get confused. Try to make that work with your airplane, because that is a totally different problem. So that's what you have. You have creating the table, answering these questions in number 2, and then separately creating a piecewise function that has something totally separate with all of the rest that we were doing there. So, all right. I think that's everything I was going over with it. That's the stuff we did earlier. Substitution, piecewise. Here's our assignment. Graphing. You can graph these things. On the second lesson is all about graphing. There are the different functions. This came straight from the lesson, by the way. So this is in Buzz. You'll be able to get this information right there. So anything you see on these printouts, all these printouts I pulled from our lesson right here. So anything here that you may not have seen all of, you should be able to find that in your curriculum this week. So let's talk about attendance. We're in week 3 now. And since we're in week 3, that means we don't have to come to every class. Like the last 2 weeks, we had to come to every class. Now it's grade based, right? So this week, this meet is mandatory, but Thursday's meet depends on your grade, right? If you're below 70%, you have to come to the rest of the meets this week, which there's only one more. There's only one B day this week. So here's how it is. Since the only grades we've had so far are the practice/homework and don't really count towards your semester grade, if you have completed those, if you have completed both of the assignments that were due Sunday, then you are considered above the 70% right now. If you do not have those completed by Thursday morning's class, then you need to be here or you are counted absent. If you're supposed to be in class and you're not here, you're counted absent. If you don't have to be here, you're not counted absent, right? So I will be here in class. I will log in. I'll be in class. If anyone needs any help with anything, so even if you don't have to come to class, I will be here. You can come ask questions. Now, if nobody's here, I'm not going to hang around for an hour. I'll hang around 20, 30 minutes and see if anybody comes. So if you need help, don't wait till the end of class. Get here 8:55, 9 o'clock, get here at the beginning of class so I know somebody's here and needs some help. So that way, I don't want to waste your time if you don't have to be here. But again, if you get all of your assignments done that was due past Sunday, you're considered above 70% as far as attendance is concerned this week. Now, this week we have that 1-question quiz. So that's going to set your grade for next week, right? So you need to do well. And you do have opportunities to take that. If you miss it the first time, you can give another attempt at it. If you miss it twice, then get with me and let's talk about why you're not understanding it, and then I can let you take a third attempt. But you're gonna have to visit with me before a third attempt, because I want to talk with you on why you've missed it twice and see what you're not understanding. Because hopefully it's one question, and if you're not getting it, we do need to talk. So, all right, if you have no questions, I will let you go. But if you do have questions, please hang around. I will be putting this video on Google Classroom of what we covered, so you can go back and review that. But go through the lesson, see what you need, and we will talk to you next time.
Let's get out of here. Word to your multiples. Math, baby. We're learning math, baby.